Hello viewers, this is Kiran Shinde, Assistant Professor IICMR MCA Pune. Once again, welcome back to the video series on multiprocessor and multi-core operating systems. In this video session, we will be talking on the types of multiprocessor systems. So let's start. As I mentioned, in this particular video lecture, we will be talking upon the three types of multiprocessor systems. But these types are actually formed on the basis of the association of CPU and memory units with each other. Hence, the multiprocessor systems are classified into three types according to the manner in which CPUs and memory units are associated with one another. The three types are: first, Uniform Memory Access Architecture, that is UMA; non-uniform memory access architecture, that is NUMA; and no remote memory access architecture, that is NORMA. First of all, let us try to understand what is UMA, that is Uniform Memory Access Architecture. In this particular type of architecture, all the CPUs in the system can access the entire memory in an identical manner. That is, the access speed will be uniform across all the processors accessing this particular memory by making use of UMA. The UMA architecture is also called as tightly coupled multiprocessor architecture. Now, in my past video session, we have already discussed on the characteristics of a tightly coupled system as well as a loosely coupled system. So I will request you just go through that particular video to understand why UMA architecture is called as tightly coupled. It is also called as symmetrical multiprocessor architecture. Again, I will request that in last video session, I have also discussed on the two types, symmetrical and asymmetrical. So do visit the video to understand why UMA is called as symmetrical multiprocessor architecture. Now, let us try to understand with the help of this simple image, which is showing the tightly coupled multiprocessors. Now, essentially, why they are called tightly coupled? Because the first and very important characteristic of a tightly coupled system is it has a shared address space. So if you see here, the main memory is connected with the level 3 cache, and this level 3 cache is actually shared across all the processors, okay, via the common communication channel. Then you can see every processor is having its local L1 cache and the L2 cache. One more image for you to understand this concept. Now here we can see there are three simple or small images. In figure A, if you see, the bus channel is shown through which the processors are actually sharing the main memory, which is shared memory. In figure B, if you see, the processors are having their local cache and they are sharing the main memory by making use of burst channel. And in figure C, there is private memory associated with every processor along with their local cache. And again, the main memory is shared across these CPUs or across these processors, which is called as shared memory. So again, these are some examples of UMA, that is Uniform Memory Access Architecture. Or rather I can say the various patterns in which this architecture is used in multiprocessor systems. Let's go ahead. The second type of memory access architecture is NUMA, that is non-uniform memory access architecture. In NUMA multiprocessor model, the access time varies with the location of the memory. Now here, the access time will not be uniform as in case of UMA. Here, the shared memory is physically distributed among all the processors called as local memories. The collection of all the local memories form a global address space and which can be accessed by all the processors. In this particular architecture, each CPU can access the entire address space. However, it can access the local memory faster than it can access non-local memory. Okay, now let us try to understand with the help of simple image. If you see this image here, you can see that the every processor, that is P1, P2 up to Pn, they are having their own local cache and they are having their own fair share to access the main memory. That is why it is called as non-uniform memory access architecture. Some more points related to this. A distributed memory multi-computer system consists of the another type that is called as NORMA. Let's go ahead and understand the third type. Why it is called as NORMA or no remote memory access architecture. Here, Each node acts as an autonomous computer having a processor, a local memory, and sometimes IO devices as per the requirement. And in this type of architecture, all the local memories are private and they are accessible only to the local processors. That is why this particular architecture is actually used in traditional machines, which are called as no remote memory access architecture, wherein there is nothing which is in the shared approach or in the shared paradigm. So if you see this particular image, there is a message passing interconnection network through which all these processors are interconnected with each other. Rather, they are interconnected with each other only for communication purpose. But if you see their processor, their memory, or the set of IO devices they are requiring, they are completely local with respect to every processor. And hence, this particular architecture is called as no remote memory access architecture. That is normal. Now, let us go ahead and discuss a very important topic, which is cache coherence. Now, I will request that the prerequisite to understand this particular topic is to go through the cache memory concept. Before we start into the explanation or the discussion on this particular image, let us try to recall what do you mean by cache coherency problem. Basically, when we say that a cache coherency, maintaining the cache coherency between data loaded in processor caches is an issue in multiprocessor system, because it can happen the same data will get loaded onto multiple processors cache. Same memory block is loaded into two processor caches. One of the processor updates the data in its local cache. Data in the other processor cache, if it is not updated, it results into inconsistency or cache coherency problem. This is in a simple language I just explained you. If you see this particular simple image, here you can see a shared memory multiprocessor approach where the processors are actually communicating with each other via this interconnection network, and they are getting associated with the main memory with this particular interconnection network on the shared memory approach. Now, in this particular typical architecture, this cache coherency problem gets arised significantly. Let's discuss on this, and then we will talk about the cache coherence uh, removal schemes, I can say. Now let us again try to understand this with a simple example. Now suppose here the processor P is actually it has shared a data block X, okay, and that particular data block X is shared with this another processor also, and the same block is in main memory also. But if suppose this processor P, the first processor which is shown in this particular diagram, modifies that particular data block, then if that modification is not done on the another processor's block and the main memory, then it can result into inconsistency or cache inconsistency, and which is called as cache coherency. Now let us try to understand what are the schemes or what are the protocols which are used to address this cache coherency problem. The two protocols which are famously used are Snoopy bus protocol and directory based protocol. First of all, let us try to understand what do you mean by Snoopy bus protocol. The Snoopy protocols achieve data consistency between the cache memory and the shared memory through a bus based memory system. We will try to see this with the help of a simple image. Snoopy bus protocol makes use of two operations to maintain the data consistency: write invalidate and write update. Let's try to see with the help of a simple example. In this first image, if you see, the data block X is maintained by processor P1, processor P2, and processor P3 in its local cache, as well as the same block or the replica of the block is there in the shared memory also. Via this bus channel, these communication of between the shared memory and the processor is happening. If you see the second image, in this particular second image, this processor P1 is trying to modify this data item X. So that modification is mentioned with the help of X1 here. Okay, it is just conveying that X is modified. So now it is changed to X1. But in that particular scenario, this modification should be communicated to other processes as well, because they are also maintaining the replica of the data item X. and the shared memory also. But in that case, if that particular updation is not conveyed, then the first operation which is imposed or which is raised by Snoopy bus protocol is write invalidate. Means at least till the time this particular updation gets reflected on this P2, P3 and shared memory, they will at least come to know that this data item X is been modified. So now it has become invalidate. The copy of that particular X data item has become obsolete. So that is conveyed with the help of this write invalidate operation. After that, if you see, the second operation which is signaled or which is raised by Snoopy bus protocol is called as write update operation. With this, what happens? The modification done by processor P1 on data item X, which was X1, will get updated, will get replicated or reflected on processor P2's cache, processor P3's cache, as well as in the shared memory. And with this particular Snoopy bus protocol will be successful in maintaining the consistency or cache consistency across all the processors and the shared memory. So that is the first approach, or that is the first scheme to address the cache coherency problem. Let's go ahead. The second scheme or the second protocol which is used to address the cache coherency problem is called as directory based protocol. Now here, what exactly we are going to discuss is, first of all, the limitation which was imposed with the help of Snoopy bus protocol. Now, Snoopy bus protocol works well if the network size is small, if the number of multiprocessors involved in the network are less in number. But by using a multi-stage network for building a large multiprocessor with hundreds of processors, the Snoopy cache protocols need to be modified. Why? Because broadcasting being very expensive to perform in a multi-stage network, and of course it will result into significant overhead with respect to network. That is why when there is a multi-stage network having large multiprocessors involved with hundreds of processors communicating with each other, that time Snoopy bus protocol will not be an efficient option or a choice. And for that, the second variant or the second scheme which was proposed was called as directory based protocol. Now let us see what exactly is the fundamental under directory-based protocol, and then we will try to understand this diagram also. In a directory-based protocol system, data to be shared are placed in a common directory that maintains the coherence among the caches. So here also you can see in this particular image, a directory entity is used. Here, this directory acts as a filter where the processors ask permission to load an entry from the primary memory to its local cache. Okay, so as a matter of fact, it actually serves as the central controlling authority in this particular scenario. That this particular directory will permit the processor to copy that particular item from primary memory to cache or not. If an entry changed, the directory either updates it or it invalidates the other caches with that particular entry. So essentially, if you see in this particular image, there is a directory which is maintained here. Then you can see there are 4 cache memories are mentioned here. And there is a data item with respect to that particular data item. Whatever updation would happen, that updation will be either communicated by the directory to all these processors involved in this particular scenario, communication scenario, or it will signal the invalidate operation. Okay, so likewise, a central controlling concept is used by making use of this directory based protocol. Okay, so this is all about the second scheme of cache coherency. So viewers, hope you understood whatever we discussed in this particular video session. Stay tuned for my next video session. Thank you very much.